Next, objective bits. First one, an example of electrophile is electrophile. Electrophiles are electron attracting species. So electrophiles attracts negative charge. Electron, what is the charge on electron? Negative charge. Okay. So generally electrophiles are positively charged species or neutral. Okay. So here different options are given: cyanide ion, hydroxyl ion, aluminium chloride and hydrogen. So electrophiles, electron attracting means having less number of electrons. So all positively charged species and electron deficient molecules, they are considered as electrophiles. Okay. So here AlCl3, this is neutral molecule. These are negatively charged species. These are not electrophiles. Okay. Aluminium trichloride, this is electron deficient molecule. Okay. It takes electrons. So this is electrophile. Okay. AlCl3 is electrophile. Next, an example of nucleophile. So what are nucleophiles? Nucleus attracting species. What is the charge on nucleus? Positive charge. So nucleophiles attracts positive charge. So that's why nucleophiles are negatively charged species and also some neutral molecules. Okay. So negatively charged species are nucleophiles. Neutral molecules, in that molecules which contains double bonds or unsaturation, they are considered as nucleophiles. Okay. So here different options: ethane, acetylene, H plus ion and alkaline R plus ion. Okay. So nucleophiles must possess negative charge. So these two are not nucleophiles now. Okay. And coming to these two, ethane is saturated compound, and acetylene is unsaturated compounds having multiple bonds. So that's why acetylene is nucleophile. Next, which of the following is not an electrophile? What is electrophile? Electron attracting species. Okay. So having less number of electrons. So here in the given options, amines, ethers and alcohols are there. So all are electron rich compounds. Okay. Having more electrons. So here NH2, amino group, on nitrogen atom, a lone pair of electron is present. And in ethers, an oxygen atom, lone pairs. And alcohol, an oxygen atom, lone pairs. Okay. So all are electron rich. So electron rich compounds are nucleophiles. Okay. So which of the following is not an electrophile? Okay. All are not electrophiles. All are nucleophiles. Okay. Next, in which of the following ortho-para substitution by an electrophile is very facile? Facile means easy. Okay. So which compound undergoes electrophilic substitution reactions very easily? Okay. So here nitrobenzene, phenol, benzoic acid and acetophenone. So different options are there. So nitrobenzene, nitro group. Okay. And benzoic acid contains carboxylic group. And acetophenone contains carbonyl groups. All are electron withdrawing groups. And phenol contains OH group. It is electron withdrawing group but not as stronger as remaining groups. Okay. So that's why phenol easily undergoes electrophilic substitution reactions at ortho and para positions. Okay. So phenol is the compound which easily undergoes electrophilic substitutions. So it forms mixture of two compounds. One is ortho substituted and another one is para substituted. Okay. Next, which of the following effects can explain the stability of tertiary butyl carbonium ion. Stability of carbonium ion. Carbonium ion is carbocation. Okay. So tertiary butyl. So tertiary carbocation. So tertiary carbocations are easily undergoes hyperconjugation. Okay. And also inductive effect. Okay. Tertiary is greater than secondary. Secondary is greater than primary. Primary is greater than methyl group. That is the stability order of carbocation. Okay. So both the inductive effect and hyperconjugation both explains the stability of carbocation. So both the 2 and 3. Okay. Next, which is least stable? Least stable. So here different free radicals are given. Okay. So dot on all these alkyl groups. Dot indicates unpaired electron and all these are free radicals. Okay. So stability order of free radicals. Tertiary free radical is more stable than secondary. Secondary is more stable than primary, which is more stable than methyl group. Okay. Tertiary is greater than, secondary is greater than, primary is greater than methyl free radical. Okay. So here least stable free radical is methyl free radical. Okay. So this is the correct option. Next, which of the following group has maximum hyperconjugation effect, minimum inductive effect? Okay. So hyperconjugation and inductive effect. So in both this, tertiary is greater than, secondary is greater than, primary which is greater than methyl. Okay. So minimum inductive effect that is shown by methyl group. Okay. And generally maximum inductive effect that is for tertiary alkyl group. But it shows minimum inductive effect. If we take tertiary carbocation there, it shows maximum hyperconjugation and maximum inductive effect also. So that's why we can take the option CH3. Okay. So methyl. This is also primary. And primary but having heavy hydrogen there. Okay. Next, the order of stability of carbane ions. So stability order of carbane ions, that is reverse to carbocation. Okay. So here primary is greater than, secondary is greater than, tertiary is greater than methyl carbane ion. So with that, aromatic carbane ions, benzyl carbane ion, that is more stable than the aliphatic. Okay. So that's why order is 4 is greater than 3, 3 is greater than 2, 2 is greater than 1. Okay. So this is benzyl and primary, secondary, tertiary. So this is the correct option. Next, which of the following has the highest nucleophilicity? Okay. So nucleophilicity, that is reactivity of nucleophile. Nucleophilicity indicates reactivity of nucleophile. Okay. Here different options are there. Fluoride, hydroxide, methyl and amine. Okay. So from left to right in a period. Okay. So nucleophilicity gradually decreases. Nucleophilicity gradually decreases. So left to right, first 4th group, 4th, 5th, nitrogen belongs to 5th, 6th, 7th group. So from left to right, nucleophilicity gradually decreases. That's why CH3 minus shows highest nucleophilicity. So this one, nucleophilicity means that is reactivity of nucleophile. Okay. Next, which of the following contains 3 pairs of electrons? So carbane ion, methyl radical, free radical, carbocation. Okay. So carbane ion. So it contains more number of electrons. So it contains 4 pairs of electron with tetrahedral or pyramidal shape. Methyl radical, it contains 6 pairs of 6 electrons. So 3 pairs of electrons and also single electron. Okay, totally 7 electrons. Whereas carbocation contains 3 pairs of electron. Okay, and positive charge on the carbonate. So 3 pairs of electrons, they are present in carbocation. Okay. Next, the hyperconjugative effect in the compounds. Hyperconjugative effect in the compounds. So here different compounds are given. Okay, what is hyperconjugation? Displacement of sigma electrons. Displacement of sigma electrons of CH bond of a methyl group, which is linked with either sp2 hybridized atom or atom having unshared p orbitals. Okay, that is hyperconjugation. So here different options: propene, alkene, okay, and another unsaturated compound. Okay, so this is 3-methyl but1-ene, okay, unsaturated compound, and 3,3-dimethyl but1-ene, okay. So here 3 compounds are given. So coming to hyperconjugation. So propene, so here alkyl group directly linked with sp2 hybrid carbon, but here alkyl group having only 1 hydrogen atom, so less hyperconjugation here. So here alkyl group having 3 hydrogen atoms, so more hyperconjugation. And here also alkyl group, so no hydrogen atoms are linked here, all are alkyl groups. Okay, so that's why 1 is greater than 2, 2 is greater than 3.